In this session, we are discussing counseling research. I'm Dr. Jan Lemon, and we are particularly going to look at experimental designs, predictive designs, and time series designs. Many of our objectives are just going to look at the characteristics of all three of those. We're also going to look at what makes an experiment validity. And then we're going to look at relationships because we're going to be talking about predictive designs. We're going to look at correlations between variables. And then finally, we're going to talk about single case research designs and the different types of those designs for practicing counselors. Let's look at the characteristics of a pure research study. Number one, comparison of participant groups. You are manipulating your groups with the independent variable on the dependent variable. Number two, always with a pure, we're looking at pure research. You have random assignment of participants to your treatment groups. Number three, manipulation of your intervention or treatment. In other words, you're doing something to that dependent variable. The next one is your measurement of outcomes. And the last one, to really have a pure research study, you're going to have to control extraneous variables because there are things that happen all the time at a research study. You may be doing a research study on school children, and in the middle of your study, you have a tornado warning. That's what we call an extraneous variable because you could not control for that. Types of experimental. Remember I said pure experimental, but there are different types of experimental. There's pre-experimental, quasi-experimental, and true experimental. And pre-experimental, there's no random assignment and no comparison group. Pre-experimental is still used a lot in education. I did a research study to see if reading circles improved individual reading ability. Now, we didn't random assign students. We were looking at the whole class, and we didn't have a comparison group, but we did have a pre-test and a post-test, but it was still considered pre-experimental. But again, it gives good knowledge to the experimenter. The quasi-experimental, this is the most used. No random assignment, but a comparison group is used. So even though you don't use random assignment, you are still manipulating the independent variables in your research. And then finally, true experimental, where you have both random assignment and a comparison group, which is really a true experimental definition. There are methods of control in experimental groups. As we've already talked about, there's the different types of experiments, and those methods of control can be many different things, where you are making sure that everything you can control, you've done. You might want to mix the accelerated students with the non-accelerated students, so you're not getting skewed results. So there are methods of control in research. I'm going to say this over and over again because it's very important, because you'll see it. The number one method of control in research is random assignment. That is the likelihood that a participant will be assigned to a treatment, control, or comparison group, and it helps ensure experimental validity and protects against selection bias. when comparison groups are used without random assignment, remember we said that the design is referred to as quasi-experimental. The example that I gave you myself, that was quasi-experimental. Still very well respected and still used a lot in the research community. All right, now let's talk about models. We're going to talk about between groups and we're going to talk about within groups. These are types of experimental models that fall within those experimental groups that I just talked about. So, a between group. Common sense would tell you that there's comparison between two or more groups. You may have two groups. One group, you're going to treat them with cognitive behavioral therapy. The other group, you're going to give them the pre-test and the post-test, but you're not going to treat them. It's still between groups. There are two groups, and the effects of the independent variable on the dependent variable is based on the examination of group differences. In a true experimental design, one group receives a treatment or intervention, and the control group typically receives no treatment. And then we have something, one model is between groups, and then we have within groups. When you do a study within group, you have one single group. And so in order to do that, you're going to measure across time with that. You're going to give them a pretest, do something in your treatment, 6 to 8 weeks maybe, and then you're going to give them another assessment. But it's going to be within that same group. When you're using within groups, it's almost always across a period of time. Now, I mentioned it a little bit, but let's look at some things and see how you feel about it. What if you do a post-test only? You're looking for a particular treatment to affect someone, cognitive behavioral therapy to affect a group that have depression. What if you only give them the Beck depression scale at the beginning, and then you do your treatment? And you don't give them a test afterwards. It's really not going to be generalizable or usual, be able to use at all. So that's not a good model, post-test only. It's easy to implement, that's for sure. But there's just no way to be certain that the scores are attributed to the independent variables. Now, we're still talking about between groups. So we could do a pre-test and a post-test control group model, which I prefer. I think it's the easiest. I think it gives you good results, and it's very simple to do. Participants are randomly assigned to a group, a treatment group, the control group. A quantitative measure is used to determine the effect of the intervention. Both groups receive a pretest, the treatment, and both receive a post-test. Well, then, of course, you can compare the pretest to the scores on the post-test, and you're certainly hoping your intervention helped with either bringing the scores down, if you're looking at something such as depression, or bringing the scores up, if you're looking at something like reading skills and ability. So, pretest and post-test is a very good model. Of course, there are always issues with that, too. Simply testing effects can affect that. You give them a pretest, they know what's on the pretest. Now, I don't know if you're like me, but I'm going to go home and look up some things. And participants will do the same thing. So that's one of the limitations is you're giving them a pre-test, and if you give them the same post-test, then they have a little knowledge of that, and that can always affect the scores. Still talking about between groups, you can actually do something called Solomon foregroup. Now, not many people use this because it's very intensive, takes a lot of time, and you actually have 4 groups. And so what you do, you have a treatment group that you're actually doing the treatment with a pre-test and a post-test. You have a treatment group with a post-test only. You have a control group with a pre-test and a post-test. And then you have a control group with a post-test only. So you have a lot going on. And then you compare all those scores. Yes, it helps remove some of the extraneous variables, but I don't think you get a lot of difference on your results. And it's, as I said, it's a really timely research study. So now let's talk about within groups. We were talking about between groups. Now we have one group. Within group, we only have one group, but we're going to do some things to them across time. So a within group design is used when change in the dependent variable is in a group is measured across time, and the participants are exposed to 2 or more treatments, and the outcome is evaluated across time. The researcher can track progress across time, and differences assessed by comparing the different groups. So the order effect of treatments is based on the outcomes between the effects of the treatments at the end. So just remember within groups, you only have one group, but you're going to measure them across time to see if there's a difference in their scores. Remember, we talked about validity and reliability for instruments that you're going to be gathering data. Let's talk about experimental validity. How do we know if the experiment as a whole is valid? Internal validity is the extent to which the independent variables truly affect the change and the dependent variable. That's what we're trying to do in an experiment. External validity, to see if your experiment has external validity, is the extent to which the study can be generalized to other settings and populations. So what are some threats to internal validity? Remember, that is the dependent variable actually going to affect the independent variable? Some of those threats are maturation. That is, if you're doing this, things can change. You never know when someone, especially if you do it with children, if you make the study too long, there's growth and developmental involved. And so just maturation could affect it. History. Something happens that creates a situation that might be a threat to your validity. Let's say you're doing a study on dating violence, and while you're doing it within this school setting, someone is abused or attacked. A young woman is attacked in the field house at the school. That's history. You didn't expect that to happen, but it messes up the whole internal validity of the research study. And then testing, as we said before, just using the instrument in itself. How reliable is that instrument? And especially if you use it more than once. instrumentation that goes along with the testing. Just as I said, statistical regression, that's something that you need to know. Statistical regression is the more you give the instrument, the more the scores are going to regress to the mean. Now, I tell students this all the time. You can take that ACT over and over again if you want to, but unless you do something like have special studying or someone to help you with it, the scores will regress toward the mean. If you scored very high, it's probably going to be lower. If you scored very low, it's probably going to be higher. But of course, what changes that is if you study hard and you get help with it. Selection bias. How did you select your participants? That could enter into it. Then you get all these interactions from all these things. Mortality, if you do too long a study, people could die. And then experimenter bias. Remember, I've said sometimes the experimenter in themselves has some type of bias that transposes to the participants. I know you're thinking, goodness, with all of those things, how do you ever get a valid study? Well, you work on all these things, and then you try to not have risk. And then if you do, you write it up in your limitations.